Hello, hello, hello. Hello, hello. Let's see. Got this.
Hello,
How you
can you
doing?
hear me?
Yes, I can hear you. How are you doing?
Okay, I'm doing well, and you?
Doing good. There it is. I appreciate it.
I
All right.
see the icon now. Thank you.
Okay, no problem. All
Okay,
right.
Prof, just before you continue, so the LSBOK is for what exactly? What is this command for?
So it stands for list block. So it just lists block devices, which block devices refer to like hard drives and solid state drives.
Okay, thank
Yep. So on the left side, these are all your drives on the left side. As you can see here, we have SDA, SDB. So these are just named in the way that they're connected on the system. So the first one's SDA, SDB, SDC. You might have one XVDC, as you can see here on the bottom when I spelled it. So if you ever see this on your system, or I can put VDA. So think about the DA just like this, like a regular disk, but the difference is this one's a virtual one. So it stands for Zen, which is a hypervisor, and then V stands for virtual. So these only come on like virtual machines, but the main ones you guys are going to see is SDA. You might see HD, HDA, HDB. So it just depends what kind of drive. If you have a hard drive or solid state, there might be different letters, but at the end of the day, you're going to see SDA, HDA. You might see NVMe. So these are the ones that you will see under this command. So when we're talking about a disk, right, we're talking about the full thing, right? And we're talking about partitions. If you go down here, if you see SDE, we can see that I have 3 partitions, right? So you can see the disk. The first one tells you the amount of storage there is, as this one you can see is 465 gigs of storage. And then now you can see out of these 465 gigs, I split it into 3 partitions. As you can see here, I have 3 partitions. Just think about it as a pizza cut 3 ways. We can see here that the first partition is 600 megabytes, the second's 1 gigabyte, and the last one's 264.2 gigs. And if you add that together, it equals 265. So our partition is when you're cutting a partition, you're just partitioning. That's why it's called partitioning, because you're partitioning out the hard drive. Like you're allocating, okay, it's 100 gigs, so 20 gigs is for this, 20 gigs is for this, and the rest of it is for something else. So that's what partitioning is. It's just you're breaking down the memory in your hard drive into different pieces, pretty much. And when you do make a partition, you have to mount it somewhere. So you see here, this partition is mounted in this area, this location, and then this part, the /boot area, is mounted here. And then as you can see here, this is the partition, but it's not mounted anywhere. So this pretty much means that you could use it for something else. Maybe there's nothing on there. You can also check with another command, which I can show you, but it looks like right now there's nothing connected to it, which means that you can probably make another partition out of it. So remember when I was talking about, like, if you guys pull up the chart that's inside the chat, which I need to put it on the actual notes for us. If you look at this chart, you can see that MBR and GPT. So depending if this is a MBR type of system, then it will only do 4 partitions maximum. You could do like logical partitions, but that's something else. But we want to focus on is on the primary partitions. So you can do 4 primary partitions, and then inside that primary partitions, you can make more virtual ones, or logical ones. But that's not that important now, because all you have to know is that the older school ones gives you 4 partitions, and the newer ones you can make 128. So for example, if I had a 1 terabyte drive, I couldn't make more than 4. Like I would have to stick with that. So with the UEFI or GPT type of partitioning scheme, you could literally make as many as you want, up to 128. If you hear the word MBR, the master boot record, that goes with the word BIOS, because they go hand in hand because of that technology. And then you have GPT with the GUID partitioner table that goes with the UEFI. So they both go together as one. So you hear GPT, think of UEFI. And then if you hear MBR, think about BIOS. And when you start with your computer, when you start it out, the first thing you get is the BIOS, where you can change the settings, hardware like details and hardware stuff. Like same thing with the UEFI. You can change certain things, certain parameters of how your computer boots. Maybe you want to change the boot disk and stuff like that. So that's the difference. The BIOS is the older one. The UEFI, you have a lot more options and a lot more things it can do. And then as you can see here, we have another partition here. This is the part. So when we're talking about partitions, we're talking about these are partitions, right? And then this is the actual disk. So this isn't a partition yet until you actually break them down. So these are partition. And then SDE is 3. You see I have more partitions in it because I use this thing called logical volume manager, which we haven't covered, but we will. So all you have to know is each time you see these little trees, that means that there's 3 partitions under here. And then when you see 3 tiers, like branches here, you can see that there's 3 more partitions in this area. So that's what these mean. And same thing up here, you see SDA that doesn't have anything. It has not, basically the disk is free to do anything. SDC, STD, as you can see that these over here, they haven't been partitioned yet. So they're just basically free disks just laying around. As you can see, my SDA, I got 1.4 terabytes in here, but I haven't used it at all. So we're going to try to do, I'm going to try to make a partition on SDA. So if you guys want to run this command, you guys can. Actually, but before anyone does, just make sure that your SDA has enough partitions. Make sure there's your virtual machine, obviously. But as long as you have enough like disk space, I'm not sure how much you guys have left, but we're probably going to like allocate 10 megabytes or 20 megabytes, something very low, so you guys could practice with it.
Okay, just so I'm clear, I'm feeling like I don't have any space on mine, so my SDA, I could be wrong, but it's showing that I have 2 partitions. One is 1 gig, one is 15 gig.
Okay.
The overall is 16. I know that's the sum, but I'm not sure if I
that's fine. And then the first partition, did they say that is mounted anywhere? Does it have like a like something like this on the side?
Yeah. The first one is to boot.
Okay. And the second one, is there anything on it?
No.
There isn't. Okay. And you said that they're both, so the first one is taking up a certain amount of data, and then the second one is taking the rest of the data, which equals out the total.
So the first one that is mounted to the boot is taking up 1 gig. Okay. And the second one that isn't mounted to anything is taking up 15.
So 1 gig, and then the other one's taking 15 gig, which is a total of 16, right?
Yeah.
Okay, that makes sense. That's probably all allocated. That's fine. That's fine. So what you could do, I'm not on the one now, but we won't like make any partitions, but I can show you how to. So later on, I'm gonna put some instructions, probably link up with one of you guys or whoever wants to see how to add more memory on your virtual machine after class. We can do that. That way you can run the commands, but it's not too many commands we're going today. We're just going with like the basics right now because this is important. And then we'll also do some practice questions for you guys to review a lot of the stuff that we've done in the past classes. This is going to help you guys to solidify your training and kind of see where you guys are at this point before we move on. Because after this class, starting next week, we're going to start learning a little bit more advanced stuff, but things are needed. Things are going to be needed. So that's why this is going to be important, because we're going to talk about LVM, so logical volume manager. And then I'm also going to draw pictures and show you guys more information and give some more background on that. But just to show you guys, so these are the 2 commands you use. So the first one is called fdisk, and the second one is called gdisk. So the first command, you use these usually for like systems that use MBR, like master boot record or a BIOS. And then the gdisk, you use this for systems that use GPT, or if it uses UEFI. And how do you know? There's a couple of ways to check. So when you start your computer, like if you go in, if it says BIOS, then it's fdisk. If you see a UEFI, then you know it's this one. And then also if you see disks like 4 terabytes or 3 terabytes, you know it's a UEFI system because it's bigger than 2 terabytes. If you see a lot of small like hard drives in there, less than 2 terabytes, and then you turn on, you see BIOS, you know it's the fdisk utility that you use. So I'll show you how fdisk looks. So I'm going to run this on /dev/STA. You could run it now. It's not going to hurt anything because it doesn't, like, anything you change isn't permanent, because you also have to write it. You also have to like at the end when you exit out, it says, do you want to like propagate these changes? Then you can say yes. But if you say no, it won't affect your disk. You should be fine. So if you run fdisk dev STA, let me just do my sudo on this? If this can open it. I think I might be using that for something, but it's not showing. I think I use a RAID array on that, but we'll try STC for now. Let's see if I can get that. Okay, so you're right. So I think I have a RAID array. So mine's a little special situation. I have I think a RAID array set up on this one. So I think I can do it on my Ubuntu, but let me try one more area. Block ID. So let's try STE. I'm gonna try STE.
I'm just letting you know I was able to execute it with the SDA.
Nice, nice.
Okay.
Okay, mine worked too. Okay, cool. So this is currently in use. So the first thing you guys can do is just press the M. This will give you the help menu. So if you press M, you can see that as a menu. So it looks like you can also make GPT partitions with F-disk and G-disks. I know they did it a while ago, but I never verified. I always use the same ones. But you can make a GPT partition with the F-disk too. So it looks like they're interchangeable. Maybe they added some extra functionality. So when you're looking at this, these are the generic commands that you have here. These are the shortcuts. These are the keys. M is to print the menu. And then if you go to the top, this is to delete a partition. If you want to delete a partition. But obviously, if you do that, make sure you save your data. And then this tells you list free unpartitioned space. So this is what you want to do. So you can press capital F. We can do that now. This capital F, and then you press enter. And then if you see on the bottom, the unpartitioned space, I have nothing. So nothing is, there's nothing for me to use. So it's basically full. So you see it if you run the capital F, you can see that how much space you have. And that's how you know how much to partition. So like example, if you have 100 megabytes, you can partition 100 megabytes. So pretty much allocate the 100 megabytes for you to do whatever you want with it.
Mine doesn't have that. When I did the F, I didn't see the breakdown.
Did you do SDA?
Did you do capital
SDE?
What was that?
Did you do SDA?
Yeah, I started with the.
Okay, so I'm going to exit out so I can show you real quick. I just want to make sure. So I use SDE because I think my SDA might be tied to another RAID or something because I have a couple RAID things set up. So when you type this command, you can get inside, right? You get the help menu too, right?
Yeah, I got
nice.
That.
Okay.
I hit the M for the menu.
Okay. Nice.
And then what came out, I didn't see the F in there. I saw the A, B, C, D.
Did you try capital F?
Yeah, I did the capital F, and then it said unknown command.
Really?
Yeah, so I think the SDA is different because mine's looks exactly like his. Even when I did the M, I think yours is a bit more detailed and categorized compared to ours.
Okay, I think it's because I'm using like an actual server, and I think you guys are using the VM version.
Yeah,
it probably would happen because of the VM version of this. Yeah, let me use my VM because I know my VM is probably going to see the same thing. Let me open it up real quick. I'm sure I'll probably see the same thing. I'm using an Ubuntu VM, so I'm going to open it. I'll just take 2 seconds so you guys can also see that. We'll do my VM. Can you guys see that?
Yeah.
Yeah.
Okay, so I'll try the same thing. So let's block. Let's try that. So I guess I don't have anything. It's been a while. This is the actual WSL. Maybe that's why. This is the Windows subsystem thing. So I don't think there's anything. Let me try something out real quick, you guys. So I'm checking the FS tab. This is where you check. It stands for file system table. This is where you mount your file systems. It looks like, yeah, though this is a virtual thing. So yeah, there's gonna be nothing here. So yeah, so if you guys
what we should be seeing is the amount of unallocated like bytes that we have.
Right here. Yeah, so right here, you should be seeing this right here. So the unpartitioned space, that's what you guys should be seeing. If you're on the regular Linux system, you guys would see this. So it'd be the same exact thing.
Oh, okay, because I saw that one of the commands that we have from the alphabetical options was V, where it says verify the partition table. Is that similar or no?
I'm gonna type in V. So you see when I type in V, it says using 3 out of 128 partitions. So that means that I'm using the UEFI system. So if you see 128 partitions, so if you see that chart that I sent you guys can see here there's 120 partitions. So that means that the system that you're on is a uses a GUID partition table. So pretty much when your computer boots, right, it uses that partition to look for the look for your bootloader and to also look for bootable disks. So that's what GPT is, or MBR is. MBR is a small little section of the first 112 bytes of the computer. So GPT is a similar structure, but GPT is able to do a lot more stuff. There might be slight differences between them, but that's how you know that if you see it here, says that I'm using 3 partitions out of 128. And how do I know that? Is because when I look at the SDE, what we were looking at, as we can see here, there's 3 partitions. That's how I know there's 3. But there's a thing called logical volume manager, which I was able to make 3 more. As you see here, it says, you see how it says here, this is a partition. So if you see the type, so if you go to the top, you see this is the disk. That means that there's the actual disk that holds everything. This is like the shell, like everything that's holding inside of it. We go to the next one, SDB. So this is the disk, right? And then we have a partition, but it's under a logical volume, which we'll talk about that later. That's all you have to know is called LVM. We're going to cover that the next one. And then if we go down one more time, this other partition here, this is the RAID 0 partition that I have set up. We can skip that. We go down to SDC. This is the disk. SDD is the disk. We go down to SDE. You can see that this is the disk, which gives you how much data is in this disk. And then we go to the partitions. That's why it's called part, because it's a partition. You have 600 megabytes. You have another partition of 1 gig. Another partition, which is the rest of the data. As you can see here, we have the /boot EFI and /boot. That's part of this partition. So we have 2 partitions here. One is SDE, which is mounted here. And then we have SDE2 that's mounted here. And I'm going to explain the mounting to you because you might see this as a foreign concept, but I will explain that. And the reason why on SDE, it says that I have no free space is because I'm using logical volume manager. So the way it works is that I basically took all the extra data that was left. I think it was like 464 gigs, which shows you here. But right now I have 390 gigs left, something like this, but whatever. But the point is that over here, they're logical volume manager. So pretty much I'm making more partitions inside of here, but using the software called LVM, which makes you make more virtual partitions. But they're not real because they're partitioned logically, which we'll explain in the next one. Then here you can see this is a CD-ROM. So I actually have a CD-ROM in my server. So if you guys have CD-ROM, is because this is being used to launch the image, your OS. So like the OS that you guys have, it's this is what it's used for. This is used to launch your OS. So it's acting as a fake CD-ROM, which is not a real CD-ROM. It's just virtualizing a CD-ROM, saying, hey, I'm acting like a CD-ROM. I do everything a CD-ROM does. It just I don't exist physically. So that image acts like a CD, like the way it acts like a CD. So that's what it uses to boot off of probably. Mine is just a regular CD-ROM. I don't use it, but it's under SR. That's the normal name for that. And then we can see here it is telling you if the disk is removable. 0 for no, I think 1 is for yes, and then the size. And then RO stands for read only. So none of mine are read only. So that means that I'm allowed to write data to the disk. If it's read only, that means you can't type anything in there. Like you can't change any files. You can't do nothing. You can just read. That's it. And then the major and minor pretty much tells you about the disk. So this one tells me what kind of disk it is. And it tells me the sub detail. So example, this one might tell you Samsung, and then it's a TV. This one's a Samsung, and it might be a watch. So think about it like that. The first one explains what kind of disk it is, like what type of disk it is. And the second gives it more details of exactly what it is. That's what the major and minor is, but it's not important to know that, but it was a good tidbit to share.
So,
And
Prof,
yes,
sorry, in the message board, I took screenshots of what everyone in this class should be seeing. So if maybe you want to use that to kind of just give us an explanation of what you're doing.
oh, on the message board.
Yeah, and just to add to that, so I know you did do the V command, but yours still looked different from what I'm seeing.
Yeah, yours.
It's not the same data to a certain extent.
Yeah, so it'd probably be different just because of the let me see if I can clear this. So yeah, so I think it's different because of the virtual machine, because the one that I'm logged in, I'm logged into my server. I'm using like a Dell server, like a really big server.
Okay.
I know you guys can't see it from here, but if I put down the camera just for for you guys just to see. So I'm using, like, if you see the server, there's a server over here. It's a really big server, has like power supplies in the back and all that stuff. So I use this as that login side of. So it's like so like all the data that you see is from an actual device or actual server that you see. So it will be different. I want to see if there's a way we can make some type of lab or some setup that way you guys can practice. I'm gonna see how I can get that set up for you guys to make it so you guys can practice some of these commands and stuff like that. Yeah, I was setting up my server to get outside connections, but I need to set it up first. And then give you guys access so you guys can try it here. I'll have like some playground. You guys can try set up the drives and all that. If I type in V, as you can see here, yours is different, like you said, right? Because you only have SDA, correct?
Yes.
Yeah. So I'll see if I can just I think there's a guide out there how you can add another like disk and make it free. That way you guys can practice. But I'm sure there's some tutorial or something that we can find to try to get that set up. But I'll look for that information and post that or make maybe a video off of that video or a referral video to make sure that you can set it up so you can practice it. But a lot of the commands, like I said, is pretty much self-explanatory. This is like if you want to change the partition type. So if you want to change the partition type, there's just different like numbers that you can lay out to it, which I can show you now. And then this is verify the partition table. You're just verifying of what do you have left, like what partitions are being used and what is it taking. I print information about a partition. So if I type in I, as you can see, there's 3 partitions. If I type in 1, it'll tell me information about the first partition. Try I, see if that works for you guys.
I think me personally, I think I'm having a hard time following, because I know Red Hat and CentOS is the same kind of system, right?
Very similar.
I'm just trying to wrap my head around why when you run your fdisk, the options that we are seeing is different from.
What are you seeing on yours right now when you run yours?
If you click on the message board, I posted everything that we are currently seeing, and we are using CentOS.
If you can add her, let's see, message board. Give me one moment. You mean the OneNote, right?
No. In our Zoom meeting.
Oh, yes. I don't have it open. That's why. My bad. Oh, I see it now. Yes, I had this closed. My apologies. I'm looking at yours right now. So yes, I do see yours. So let's see yours. Yep, it looks like the commands are slightly different. We can see you have toggle bootable flag, edit PSD disk. Yes, you have a lot more options, it looks like. G, you do have G. Yes, it looks like they're just like the options are not as organized. It looks like you have them all in one place, and it looks like you have some extra options. And then you said your LS block, you have SDA, and then you have SDA2. As I can see here, you have a partition for boot, and then you have a second partition was 31 gigs, and then you have LVM partition for your root, which is normal. I think that's what you, yeah, that's pretty much for your whole file system. I can see that. All right, yeah, it does look slightly different. Yes, but it looks like the LS block worked for you. That actually gave you some more partitioning information. So for yours, let me see yours. So the one that you want to try to run that's similar to I. Let's see what options you have. List, create, verify, V. We have the same one. I don't see I. Print information, print the partition table. You can try P. Maybe it might give you similar. I'm trying to look for information on here. So P, I think P. So you can try P, see if that gives you a difference when you run the command. What do you get when you run P?
I just posted it in the message board.
Okay, so this is giving you more information. So as you can see here, the partition is giving you more information. It tells you here, you have dev STA, and then you have dev STA 2. So you have two partitions, and it tells you like the start, where the blocks start and where the blocks end. As you can see, the second one, you see it starts with the next block. You see how the first one ends at 199, and the second one begins at 200. So this is telling you like the amount of where it begins on the blocks, where does it end, and then it tells you the amount of blocks being used. And you see the ID, that's telling you what type of partition it is. So that number 83 is linked to Linux, and number 8E is linked to Linux LVM. So if you type in the L, like if you type in L on your side, and I think on my side is L also, you see this? These are all the partition types that you can assign it. So when you make a partition, right, you can give it different labels. These are just labels. I can give it Linux Home. I can give it Linux RAID, LVM if I'm using that technology. If I'm making a swap file, which we'll go over in the future lessons, you can give it number 19. So what you see here, when you see ID, that's what it means, this number right here. And then on the right side, you see system. It's talking about this value here. So for yours, it says 83. If I go down to 83, you see for my system, 83 equals net PSD RAID. And then for yours, it's 83 ID equals 80 ID number 83 equals system under system equals Linux. So yours is different from mine, like you said, and it looks like it's different for sure. So for mine, if I wanted to do a Linux, just Linux by itself, I would have to look for that. I don't see one. I'll probably do Linux Home, most likely, looks like, but that's like the home drive. But yeah, my other system on the Red Hat, yes, you do have Linux, because I'm using like a different version of it. So yeah, I don't see that one on there. Let's try gdisk and see if we can see something different, you guys. So let's try the gdisk command on the same drive that you just had. So try gdisk.
And also just a quick note, I know majority of us are all on the CentOS. So if maybe for our next class, if I don't know how hard it is for you on your end to maybe utilize the CentOS for us going forward.
Yeah, I can do that.
Yeah, just to make so that we are all uniform on the same type.
Yeah, no
Because
problem.
I know the Red Hat, trying to get the Red Hat, I know it's like a paid subscription. So
I can give you guys, I have a free image. I can just send you guys the Red Hat image if you want. Or I can use CentOS, whatever you guys want.
Yeah,
whatever is easier. Either one.
Yeah.
Either one's different.
I know everybody currently has been doing everything on the CentOS, so I wouldn't want to complicate things.
That's fine.
Yeah.
So try to run gdisk and see what you guys get. See if you guys get anything here. On mine, it says found valid GPT with protective MBR using GPT.
Yeah, for the SDA, on mine it says command not found.
Okay, so that means that that's not installed. That's fine. We'll just go over the concept of it. It's pretty much just like fdisk, except this one you mainly use it to partition out GPT disks. Looks like the fdisk you can do it also. So like I said, fdisk and gdisk, all it is to partition your disks and delete partitions. That's all it's for. In a simple way. And I'll see if there's other ways you guys can practice with like some empty disks to make partitions. But just in a nutshell, fdisk and gdisk, all it is for partitioning. That's it. Just to partition disks out. Just like on Windows where you have that disk, I think it's called disk
utilities, I think it's on Mac.
Yeah, something like that. Yeah, that's like partitioning. Like example, let's say like you have a partition, you want to make a partition for all your music collection. You can make another partition and you mount it at /music, and then /music is where you put all your music in, all your stuff in that you want to use. And over here, it looks like you have to use question mark to access the menu. And then L, I'm gonna type in L to get the actually let me escape out of that one. Try that again. Question mark. Let me see what partitions I have. So I'm gonna see where is it? We have list, print partition table, we'll try P. As we can see, I have 3 partitions here. Number 1, number 2, number 3. As we can see here, the first partition, this is my boot partition, and there's my EFI system partition. And then from here, I have 2 regular partitions. And it tells you where it starts and where it ends. And then it tells you the size, it's 600 megabytes. And then the code just tells you what kind of system it is. Like it's just a label. It just tells you what label it is. And each code is linked to a label, like Linux, Solaris, or whatever you want to put. That's it for that. Just Gdisk and Fdisk are for partitioning. And like I said, I'll get the CentOS or get the VM for you guys so we can see if we get the same results on the commands. So the next one you guys can try is cat and then /etc and then type in fstab, which stands for file system table. And then when you guys get a second, I'll tell you or show you guys what it is.
Okay, so before we move on to this one, I just quickly want to know what's the difference between the Fdisk and the Gdisk?
So
And a case scenario where you would need to use one or the other.
Right now it looks like they're kind of interchangeable, but technically the Fdisk is used for like older systems. So like disks are less than 2 terabyte or BIOS-based systems, and then Gdisk is usually used for systems that are to use a GPT partitioning scheme and or use 2 terabytes or more on the disk. So if we go to the man pages on Fdisk, we can see here manipulate disk partition, and it says now it does both of them. So it looks like MBR and GPT. Before it was only for I guess BIOS systems or basically disks under less than 2 terabytes. But we can see here it has cross compatibility. You can do both of these. And then for the Gdisk, we can see here we have the interactive GUID partition table. So pretty much that's what GPT stands for. As we can see here, the Gdisk program employs. So all you have to know is that usually the Gdisk helps with the GPT partitions, and then the Fdisk is MBR. You know, usually by standard, you want to use Gdisk for GPT or UEFI systems, and then Fdisk is used for systems that are BIOS or ones that are less than 2 terabytes.
Thanks. So I would like for us to stop real quickly before we go into the next topic and pick someone in the class to kind of recap what we've learned so far.
Okay, no problem.
So I'm gonna pick Bafo. What is I took some notes. So what is lsblk command used for? Bafo, are you in class?
I'm in class. What you LSB command used for?
Yep.
Or ls block, this one.
Right, it lists all the stuff.
What's
List the SDA, SDs, and then
Yes.
The
further breaks it
partitions.
down to
The partitions.
Mm-hmm.
Where you have the partitions.
Yeah, so that's part of it. So yeah, it lists partitions too, but it also mainly is to list like all the hard drives and its partitions.
Mm-hmm.
Hard drives, SSDs, or NVMEs and their partitions. So when I run this again, you can see it lists all the block devices. These are the block devices, right? All of these. And then it also lists the partitions. That's it.
All right. So make sure you guys update your notes correctly because we will ask this question again.
Yep. And then also to know, the ls block partition also tells you where the partitions are mounted. So like this partition SDE is mounted to this. So to make it easier for you, you know how we make directories, right? So if I make a directory called data, right? And I make a partition of 100 megabytes, and that partition of 100 megabytes, let's say I use a file system, like let's say I use ext4, XFS, or NTFS, which is the Windows one. So you have to format the disk. So when you format it, that means you're basically giving it a brand new partitioning, not partition scheme. You're giving it a file system. But I'll take away that because I don't want to add too many things. All you have to know is that partition gets linked to a mount point. So when you make a directory, like let's say you make a directory called data, and then you make a partition SDA1 with 100 megs. When you mount that when you mount the disk to the actual mount place, like data, that means there's 100 megabytes of data that you can write in there. So you can save your pictures, your videos. Each directory that you see, it's mounted somewhere, and they're usually mounted to a partition. So again, when you have a partition, that partition gets mounted to a directory. That's all that means. So when you see here, you can see SDE is mounted to this directory. You can see SDE1 is mounted to this directory, and then this is mounted to that directory. So each one is mounted to a certain directory. Like you see /home is mounted to this partition. So, and this partition has 390 gigs of data. And then the other command is ls/usb. You guys can type this in. So if you type in ls/usb, it tells you all the USB devices connected to your system. Did everybody get output with this command? List. So remember, ls stands for list. That's the way I look at it. List USB. Did everybody get something out of ls/usb? Any output at all?
For mine, it says that command not found.
Yours says command not found?
Yeah.
Okay. Did anybody else get? I'm pretty sure everyone else got it then if everyone's using CentOS.
Yeah, it's just the same thing.
Okay, that's fine. I guess I'll find out what other commands are on there for your machine. So just this is a very simple one, so it's not too much to do. Usually when you use, most systems will have this one, but it might not be installed by default. You could technically install it, but all you have to know is ls/usb just lists your USB devices. This is a really simple command. There's not much to it. It just lists your USB. That's it. And then the next command we're going to do is cat etc fstab, which stands for file system table. And once everyone gets here, just let me know.
Yep.
Okay. So everybody good?
Yes.
Okay. So when we are looking at this output, this is where you mount things to be persistent. So etc fstab is for persistency, right? Or to be persistent. So the reason why you use this is because when you mount, let's say if you make a partition and you mount that to /media, and your /media has all your pictures. So if you don't have it, this file is read when the server is booted. So when the server is booted, it mounts that file system to that partition for you. So if you don't do that, then every time you reboot the computer, you have to mount it again. That's all. So each time you mount the computer, instead of you doing it, this file will do it for you. That's what fstab is. It's file system table. And we'll go over it really quick. So on the left side is the device. So I know you guys see /dev mapper rel home. This is the virtual, this is the logical device. It's not real. It's like your virtual machine. This is the fake disk. This isn't a real disk, but it uses LVM. What you need to look at is on your side, you might see SDA or whatever the name is on the left side. So the left side, like I said, are devices like hard drives, logical hard drives, virtual hard drives, anything that you can think of. That's a device that has data, like a block device. The next section here is the directory where it's going to be mounted to. Like this one is mounted to nothing. This one is mounted to RAID. This is mounted to home. And this one is mounted to the boot EFI. The next thing is the file system. So we have XFS, we have unmount, 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 we We have VFAT, XFS, this is swap, and this is ext4. So all of these are different types of file systems. This is what it's put here. And then the next one are the options. So you can give your file system or like your file system options. So here you have default options. So whatever defaults there is. Over here, it gives this file system a UMask. So basically, you know, when you make a directory and by default, it might have our rewrite, execute, read write. So all this is doing is manipulating that. So when you make directories and files, it will have different default permissions when it starts. And then the short name, I forgot what this one is, but we can look this one up. It's not too big of a deal. This isn't something that's really prominent, but this is another shortcut, which is probably in the manual pages. And then 0, we don't really use that no more. The second one is the boot option. So the number tells you in order where you want to boot. So like when you're booting your system, the numbers here will signify in what order that you want the file system to check. So actually, let me correct myself. It's not for booting, my bad. So what I mean is that this is how the file systems are checked. So basically, when the system starts, it will check the system for like errors or anything like that, and this is the order that it checks in. That's it. So this is 0. This is number 2. So this will be the second one that's going to be checked for any errors. And then this one's 0 because this is the first one, which is the root directory. So this is the first file system that's checked. So to say in a nutshell, the file system table, this is called the file system table. This file system table is to have your file system mount or be mounted automatically, or else you're going to have to mount it manually. And then I'm gonna show you guys something, but you guys on this one you won't be able to follow along. But once I get to CentOS and get everything set up, I'm going to give you guys instructions. This is the logical volume manager. I just kind of want to show you how it looks like when you're mounting stuff. So let me see what I have. So right now, this will be in the feature class, but we're going to be looking at this really quick. The reason I have to do this is because I know I want to show you guys an example. And I know that no one has a disk right now, but I should have looked ahead and got that ready for you guys. So I have VG0. Okay, cool. So right now I'm creating a partition. So, but it's a logical partition. It's not like a real one. It's a fake partition. So how this LVM works, which we're going to go over in one of the classes, if you have a hard drive, right, you use that hard drive and you make a volume group. And that group, I can call it group 1, right? But the data in there, it's like a pool of data. And then when I make logical volumes, I make it out of that pool. So if I have a hard drive called SDA, and then from there, I use logical volume manager to make a group. And then that group is called pool 0. It's the pool of data that I grab. So let's say if the SDA is 1 terabyte and I make a pool of 1 terabyte, that means I have a pool of 1 terabyte. And each time I want to make a drive, I can just say, hey, I want to make a partition. I can just basically say, hey, I want 100 megs. Okay, I want 1 gig. And then I want another 1 gig. So I can pick. It's the same thing as regular partitioning, except it's more of a virtual thing. So it's the same exact thing. Right now, I'm just doing this to show you guys how it looks like when you're making a partition with LVM, and then also to show you how it gets mounted and stuff. So I'll go over it. So the first one is LV create, and then we're going to do the name. We're going to call it practice partition. And then I'm going to give it the size. The size should be, I'm going to do 1 gigabyte. And then I'm getting it from the volume group, because the volume group has like 300 gigs. So I'm basically saying, hey, I want to make a partition out of volume group 0, and I want 1 gig to partition out. So let's see. I think it's capital L. Let me do sudo. Make sure I did it correctly. Okay, nice. So now I made a logical volume of 1 gig. And if I do ls block, as we can see here, where is it? As you can see here, so from SDB, you see here, I made, so out of the volume group, which has the volume group has how much data? So out of the 3.6 terabytes, I'm using all of that data. And then over here, I made a volume group of 10 gigs. and then I have another one of 20, but whatever. But if you see on the bottom here, I have a partition of 1 gig. So right now I made a partition of 1 gig. And this is what I mean about mounting your system is you want to make a directory, right, where you want to mount your data. So I'm going to call this my music folder because this is where I want to put all my music. I'm going to use sudo because it's in the root directory. And now if you want to mount it, you use the mount command, and then I specify the partition. So first I need to specify the partition. So it's under STB, I think. So B. Actually, sorry about that. Let me double check. So this is under a weird partition, actually. This is under somewhere else. I'll show you where this one's at. All right, so usually the partitions are like on SDA, but the virtual ones, they're on somewhere else. But like I said, this is the class that we're going to cover later on. I'm just showing you this so to see how to mount stuff. So if you had a hard drive called SDA and you made a partition of SDA1, you'll do the same exact thing that I'm doing now. Like there's no difference. It'll be the same exact thing. Usually like you see the SDs are under device, like SDA or whatever's under here. But in this instance, it's under this thing called mapper. So VG0, and then I think I had practice partition. So let me see. So under dev.
So sorry, so the partitions that you make using the LVM, you're saying that those will be on the mapper?
Yes. So
Okay.
the ones from MVMs are usually here. So if we do ls dev mapper, you see, and then you do this, you can see VG0 practice, you see. It's under there. Because yeah, so the mapper is basically to map like a physical drive to a virtual drive. So you see this is like fake. It's not fake, but it's virtual. Like for the computer, it doesn't know the difference. It just knows that, hey, it acts like a partition. But in this instance, we're making a partition here. I made the partition to show you guys. So all I have to do now is use the mount command. So MUNT, and then I'm mounting this partition from the drive, like 1 gig of drive data, and I'm mounting it to music. So I have to be super user to mount. So, okay. So the reason why this is probably saying this, music 1 FS type, I think I need to make a file system first. That's why it doesn't work. So once you make your partition, it's just like Windows. When you make your partition, right, there's nothing on there. I have to use this command. It's called make file system. And I'm going to make a file system called ext4. Have you guys ever seen this? ext4 or ext3, anything like that?
Nope.
Okay. So it's just like a file system. Have you ever seen FAT, like FAT? Like on USBs? If you haven't, that's fine. It's just a file system scheme. That's it. So when you make your partition, there's no data, there's nothing. You have to put a file system on there. Without a file system on there, the data can't be organized, and then the operating system won't be able to know how to handle it. So anytime you make a partition, you have to have a file system. You might have XFS, EXT, FAT for like USB drives. So everything has one. So if you ever put your computer, your USB in your computer, and you see, can you please format this? This is what it's talking about. Like formatting it with a file system, like deleting the data and formatting it and putting a brand new file system on there. So right now I'm putting a file system called file system. Let's see which one there is. We're going to do ext4. You see MS-DOS? That's the file system also. So we're going to put ext2 for this example. So right here, I'm saying make a file system, and the file system is ext2, and you're going to put it on this empty partition. And once I do this, I'll put sudo on here. And once I do this, you see it created a file system, right? And it tells you some other information here. All you have to know is that I created a file system. Now there's a file system on here. Now I can actually mount it. So now I use the mount command. And then I say I want it to mount to music. Keep forgetting the sudo. And now I mounted it. So if I do the mount command, right, and then I use the and then if I use the mount command, as we can see on the bottom, it's mounted. We can also use the grep command. So if you guys type in mount, which grep we're going to go over, which is regular expressions. We haven't went over that, I think, yet. So if you use the mount command, basically instead of getting all that data that's coming out, it's just too much data to look at. You use this thing called a pipe, which is on top of your enter button. And what this does, it grabs the data from one command and it puts it into another command. That's all it does. So like if you're using a blender, right, you get the fruits, you put it inside of there, and then from there you put it inside your pan. So, you know, if you're making a sauce or you're making something, think about the pipe as transferring to another tool or to another utensil. So like when I get the mount command, instead of getting all that data, I'm grabbing the data and I'm putting it into this command called grep. And what this command does, it looks for specific letters and words. So this one is looking for something called music. So if I do grep music, as you can see, it basically grabbed the data from here and it filtered everything out and it looked for something called music. So as you can see here, my partition is now mounted on music. And it tells you the type of file system is ext2. Over here, it tells you is read write. And then there's some other stuff that is not too important to learn for now. But all you have to know is that it says is read write, which is you're able to read and write to the file system. But remember, I mounted it now. I mounted the partition to that directory. So that means that directory now is available to put files in there, because if I make a directory, right, I want to mount it to this disk. That way the data is saved on that partition. So now if I want to write something to it, I can actually go to cd/music. Now that I'm here, I can like touch a file. I can do file1.txt. And the reason I have to do sudo because in the root directory. So if I do ls, we can see here, now we have file1.txt. And if you see lost and found, this is part of the file system. When the file system is made, it usually has a lost and found folder, just in case like you turn off your computer or anything happens, data can be lost. But all you have to know now I made a folder inside that partition. So if I do pwd, this music directory is linked to this partition. So usually this partition will be like SDA, SDB1, SDB2, SDB3, or SDC, SDD, SDA2, whatever it's called. But all you have to know is this partition that we just made, we partitioned it, then we put the file system. And now that there's a file system, then you mount it to a directory. Now that directory, anything you put in there is saved in that partition. So now all the data is saved there. Any questions at all?
Yeah, I have one quick question for clarity.
Okay.
For that command where we made the file system, for the LVM, I see you have mkfs dot, the dev and mapper, but what is the VGO?
Oh, volume group 0.
Okay.
Yeah. So like this is for LVM. We're going to go over this. That's why I want to go over some of the basics here. I wish it was working for you guys and we have a disk to do it, but and then on top of that, I have a RAID, a RAID already allocated. But all you have to know is that you're just making a partition. So the volume group 0. So, okay, volume group. So the first part of this is acting like a disk. So pretend volume group 0 is SDA. Just pretend volume group 0 is like SDA, like a hard drive, right? And then the second part, this is the partition. And the partition I made was 1 gig. So the first part is the disk. The second part is the partition. But the reason why it's under mapper is because it's not an actual disk. It's a fake disk. So if I get SDA and it has 1 terabyte, but I get 100 gigabytes, and then the 100 gigabyte, I made it into volume group 0, which is pretending to be like an actual hard drive, which is not. And then VG0, I made a partition called practice partition. Does that make any sense?
Yeah.
Does it make more sense? Okay. If it doesn't, let me know. I just want to make sure that you got it. And remember, anytime we make a partition, you guys, it has to have a file system. So the difference between a partition and a file system is a partition is just a chunk of data that you're reserving to use, but you can't do nothing with it until you format it with a file system. So think about it like this. Think about like a drawer, right? You have a drawer and pretend the drawer is empty, right? There's no drawers. When you make a file system, It's like you're partitioning out the drawers, right? So let's say there's nothing there, but you make 2 drawers. Now you have 2 empty drawers, right? So the file system is the organization, like A, B, C, D, E. So you can make 4 partitions. Maybe you can make 4 drawers in that cabinet. Somehow you can just build it construction-wise, make 4 drives. But when you open it, there's nothing in there. So you can't save data because your computer is not going to know, how am I going to find the data? There's no structure to it. So a file system are files, like whatever file you want to put in. It is called the system because there's a system of how to grab the data. So it's called the file system because there's a system how to grab the files. So if you're looking inside of a file cabinet, there's a system. It's either A through B, it's Z through A, whatever system you have, whatever naming convention you have. So you have to have a file system. So when you partition that data from the hard drive and you say, hey, I want 4 partitions, right, of 25 gigabytes each, you have 4 partitions of 25 gigabytes each, but you can't do nothing with it because there's no file system on there. So you have to, per se, format it to a file system that's similar. So for Windows, you might use, most of the time you use FAT, which is on USBs. You might use MS-DOS, NTFS, but the difference between is each file system works slightly different. They have advantages and disadvantages. That's the only difference. They're used for different things. Some might be better at certain things for others. Like example, let's say if I had a file system, right? Starting from A and into Z, what if I need a file system for numbers, for invoice numbers? So invoices don't start with A and Z. Invoice will start with numbers. And like the ones are like the oldest ones, and then as you go up are the oldest one. But all I'm saying is that the file system is just a system to find files or in how to find the files. So the first part, like I said, is to partition the drawers, and it's empty, and then you make a file system. And then that's when you pick the file system. Now that I made a file system on music and I used the file system called ext2, now I put a file in there. Now that the file is in there, it's organized. It knows where to find it. So the operating system knows how to interact with it. So without a file system, partitioning doesn't do anything because partitioning is just partitioning data. And then you also have to partition data because if you don't partition it, you won't be able to use it how you want. So remember, partitions are just is a blank state to use to put files in there, but you can't put files in that storage that you reserved because you haven't put a file system on there. Does that make any sense?
Yeah, I have another question. With that being said, can these files be live before you even make a file system, or do you make the file system before you make and then you figure out what files need to go into that system?
Yeah, so you make the file system first, and then you can just copy over the files into that directory or whatever you want.
So the files could actually be live sitting somewhere else.
Yes.
And then you can move in it. Okay.
Yes. So you first make it, it's empty, and then once it's empty, you can just transfer the files in.
Okay. Thank you.
Yes. And then we're gonna go. So the make fs command, that's what we use. And then if we use the cat command, remember, you guys, this is used so you can actually have it ready, because if I reboot my computer, it's not going to save, it's not going to be mounted again. It's going to be unmounted. So when I try to access my data and music, it won't be there. It won't exist because that partition isn't linked to anything.
But in that case, the data will still be the LVM drive. It's not mounted to our current file system that we got logged in, or system that we.
Yeah, so basically you won't be able to like access it and use it how you want. Like if other programs are using that, let's say if you have a log server and actually, I'm sorry. Let's say you have a backup server, right? And that backup server goes to music every night at 12 a.m. And every night it goes to that directory and it basically copies all the music and it saves it onto the backup hard drive, right? So if it's not mounted, it won't be able to access that directory because that directory is unlinked to any hard drive or partition, I mean.
Right. So the music folder that is mounted to will not have nothing in there, but in the back end, in the LVM,
it'll still be there.
Okay.
The data is still there. It's just you have to mount your file system. Like if you open up your let's see what we have on Windows. I know everyone's probably using Windows. If you type in create and format disks, you can actually see here on your actual like on your Windows, you can see how you have partitions. You have the C drive, like you have a C, you have a D, you have different ones, and then those might be broken up into more partitions. You might have like you might have more than one partition or you don't. But in that C drive, you see that you have multiple things. You have like you have like multiple directories. You have, documents, music, you have many other things. So just remember, if the C drive isn't mounted, the data is still there, but you won't be able to access it from your operating system.
Got it.
Like,
So I have a question. So let's say right now in our current environment, or each one of us, right?
Yeah.
We have a file system already. Let's say we have additional storage that is not currently being utilized of, let's say, 5 megabytes or 5 gigabytes. Can we partition some of that 5 gigabytes to make it an LVM?
You can. So 2 things. The first thing you're going to have to do is to make the file system smaller, and then you can change the size. Let me show you a picture. Let me get a paint picture and show you why you want to do that. Well, first time I heard this concept, I didn't really get it, but okay, sorry. I was reading the message, so I'm going to share my paint. All right. I have my paint ready for you guys. So think about it like this, okay? You have a huge disk, right? Okay. So this is a disk, SDA. Let's call this SDA, right? So SDA. All right. Now that I have SDA, now I want to partition this. And this partition, I want to make the first partition. Just pretend that this doesn't have a boot record or nothing. Just pretend it's an empty one. Pretend it's SDB, because SDA usually has a boot record. Well, let's not talk about the first one. The first one is reserved. We'll put this one reserve. This is reserved, so we can't touch this. So if we go here, let's say that it's empty. The partition is empty. I want to make something, right? Usually when your server is started, right, or your computer, you have partitions, right? So let's say this partition is for, let's say I want to make this for music, right? This is perfect for music, right? I'm going to use this one for music. All right. And this is already mounted or whatever. So let's say if I want to make another partition, let's say this is already here, the SDA disk is existing, and you want to use it to make something. Let's say I take this much space, okay? And this much space, I want to make this partition for my documents. So I'll put docs. Okay. And let's say this partition is taking up 20 gigabytes. Okay. So, but the problem is, now that I have this partition made, there's no file system on there. So it's not going to do nothing. So the next thing I have to do is put a file system. So let's say the file system is NTFS, New Technology File System. This is from Windows. So first you have to give the space, and the second you put the data that you the file system that you want. Over here is empty. There's nothing here. So I can make more partitions out of here. So let's say that you want to make this smaller, right? You can't just make it smaller, because what happens if you make this smaller, the blocks, let's say there's a certain amount of data that's used. So let's say it's block 200 to block 10,000, okay? And these blocks is where your data is saved. So a lot of like the headers, the files, all the metadata that tells you about your file system is in there. So if you make it smaller, let's say you want to cut it in half, and you just cut it in half now, your system will be corrupted. Like your data will be corrupted, because all the data here that tells you about like where the data is stored, how big it is, all that good information is going to get corrupted. So the best way to approach this, because if you make it smaller, you're deleting some of the files or whatever's in those locations. So the way you do it is, the first thing you have to resize it. So the first thing you have to make the file system smaller, because when you make the partition, let's say the partition is 10 gigabytes, right? 10 gigabytes. And when you make the partition, when you put the file system takes everything. It takes the whole 10 gigs because that's where you're storing your data. So in this instance, as you can see here that the file system, then TFS took the whole thing. So what you need to do is delete it. And the way you delete it is you have to resize it. Now, instead of it being here, you're going to tell it, hey, you know what? I want to make you smaller because I'm not using all the data here. So you make it smaller. And then when you make it smaller, right? Actually, delete that. It's a bad example. If you make that smaller, it'll be here. And then we'll just delete this. So the first thing you have to do is make the file system smaller. Because when you make the file system smaller, you're basically letting it grab all the data and combine it into one. Like basically like the area, like if you're making it from 20 gigs to 10 gigs, then you give it time to grab all the data it needs to put it in that one area. So think about it like this. If your bedroom has stuff everywhere, and let's say someone wants to come and use half the bedroom, and if they use half your bedroom, half your stuff will be missing because it'll be on their side of the room. So what you do is like, hey, I want you to be smaller because half of the room is going to be used. Then you'll grab all your stuff in the room and you'll put it on one side. You know what I mean? You might have space there, but that's what making the file system smaller. So the first thing you do is make your file system smaller. And once your file system is smaller, then you resize the partition to make it smaller. Because if you don't, you might overwrite data or important things that you might need. Even if your file system is empty, like even if there's nothing there, you still have to make the file system smaller, or like you still have to do it because there's data in there that basically is needed for it to be complete. Does that make any sense to you guys? If it doesn't, please let me know.
Yeah, I think it do. So realistically, it will be once the initial drive for the file system has been created, it's best to just leave that alone and just add a new drive to the system.
Not necessarily. I mean, all you would have to do is just make your file system smaller. That's it. So I'm not sure. It depends what file system you're using. There's commands like if I go onto my if I go to my terminal, so for my LVM, so remember I made 1 gig of data. So let me unmount my let me see. Let me unmount the directory first so I can show you. Oh, you see how it says it's busy is because right now I'm inside of it. So I have to leave. I have to get out of it because it wouldn't let me unmount it because it's being in use. So now I just unmounted it. So everything is good. So now if I want to make it smaller, what I can do is use a command called LV, and then you can do LV resize. So that's the command that we use. We want to make it so the logical volume or the volume, we want to make it smaller. But let me use the man command so we can see. So it says here, LV resize a logical volume. So now I have to look up how to make it smaller. This command pretty much does all this stuff for you. So the first thing I have to do is type in resize fs. So this will resize my file system and it will make it smaller. So now I can use this command, type in dash, hold on, what was it again? I just totally forgot, feel like an idiot. So we'll do man, it happens sometimes. So dash R and then capital L. So cool. So dash R and then capital L. So dash R resizes it for you, so you don't have to tell it anything. So this command is smart enough to know, like, hey, if you want to make it 500 megabytes, then we're going to resize the file system first, and then we'll make it 500 megabyte smaller. So if you run this command, hold on. I think I got to be more specific with this. It says, let's try sudo. Let's do sudo. No command with syntax, LV resize. So
You have like double spaces in there, like after the sudo. Does that matter?
It doesn't. I can do it. It usually doesn't. But we can run that. So it says resize an LV by specific size. So I did megabyte. So I think MB, they don't want to be there. All right. So now I'm going to do it again. Now I got to tell it which logical volume. So the logical volume I want to use is, let me save this really quick and let me get the logical volume because I forgot the actual name of it. So we're going to do ls dev mapper. And then we can see here, this is the one that I want to make smaller. Actually, not this one, the VG partition. Remember we made that one. So that's the one that I want to use. So we'll do this command. So it's saying logical volume resize. I want you to resize the file system and I want you to make it 500 megabytes. So the first thing it does, it resizes the file system, it makes it smaller, and then it makes the partition smaller. And then you're telling it what partition you want to make smaller.
Prof, quick question. I think
Yes.
I got lost a little bit. So the file system, right, is basically the EFX or the NTFS or those things.
MS-DOS. Yes.
Why would that necessarily take up space, or why would we need to resize that?
Okay, because when you make a file system, let me do the picture again.
Yeah.
So I can show you guys.
From how, like, from just a normal person, from how I'm seeing it,
No
I'm
problem.
seeing that that's like the template. I wouldn't expect it to take up like too much size.
Yeah. So
than
it's
the actual data that's going to be added into it. So why would we like?
So it's not really about. It's more about. Okay, there's a concept, right? Remember, I think I talked to you about the super blocks and stuff like that. So the way it works is that I'm going to make a picture really quick. So let's say here in the documents, right? So over here, they have little points of data, right? Basically, it's like, think about like a lynx. Think about a Christmas tree and there's lights, right? If you take one light out, it kind of messes up everything, right? So inside the actual file system, like just pretend that this is a timeline, right? A timeline, right? And like right now, this is 10,000 bytes. And then we get here, this is 300,000 bytes, right? Let's pretend. And then if we get here, it's 0 bytes because this is the start of the disk, right? So blocks. So we start from the 0 block. Here's a 10,000 block. Here's a 30,000 block. And then this one starts from the block 200. So we're going to do block 200. Okay. So when you make this space, right, even if it's empty, it has on the timeline, it has little markers, little tiny markers, right? And these markers, you call them super blocks. And it tells you information about where everything is stored, where are the backups. So when you make it smaller, it kind of destroys the data that's kind of like talking with each other. So that's why you have to make the file system smaller. Even if there's no data, there's information on there, like metadata. So metadata is like data about data. So like if I had metadata about my food, we'll talk about, oh, it's chicken, how it smells, how it tastes, what color is it, where did it come from, is it organic? That's metadata. So it's data about data. So this data is data about the file system. So when you make the file system smaller, even if there's no data, it can corrupt some information. So you always have to make sure. And remember, when you're saving these blocks, you don't know where it's saved. Like you don't know what location it's saved. You don't know if it's being organized or the data is being fragmented. You just don't know of how it's being used. So that's why you have to resize your file system first. Resize your file system first, and then you can resize your partition.
So the file system can also grow.
Yes.
Okay.
Yes, but there is some file system that cannot shrink but only can grow. So there's a file system, and that file system is called XFS. That file system, if you ever see that XFS, that file system can only grow. You cannot shrink it.
Gotcha. Okay.
Some file system has the ability to like reorganize itself and become smaller, but XFS cannot get smaller. So there's some, like I said, there's benefits and there's benefits and no benefits on some of the file systems. But for example, in this instance that I was showing you guys real quick, so we'll do this. We're almost done with this section because this is all we're talking about today. And then we'll do some follow-up questions and some quizzes and stuff. So over here, the reason why it wasn't working is because you can hear this logical volume path. Remember absolute path and all that stuff, so it needs the path of where the volume is located. The logical volume path this is the path. So it needs the path of it. So Yes, I think I spelled it wrong too. I said practi part. There's no C in it. So you see when I did this, you see what happened? The first thing it did, it ran the resize command, resize file system. It says resizing the file system of dev mapper VG0 from 128,000 4K blocks. And now it's so I guess it shrinked it to this size to 128. And these are the blocks. So basically they're chunks. They're in 4K blocks. So think about Legos, right? Some Legos are longer and shorter. So basically the blocks, they're like maybe let's say that there's medium sum Lego. So all the 4K blocks is saying is that, hey, we shrink the file system and they're all divided in 4K blocks. So it's 4K blocks and they're all divided into 4K blocks. So it got smaller. And then the next thing is size of the logical volume has changed from 1 gigabyte to 500 megabytes. So I'm now, if I do ls block, you can see here, it's not 500 megabytes. And that's the proper way to resize your file system. If you resize it the wrong way, like you can actually corrupt your data.
Got you. I think it makes sense now.
Yes. But the good thing about that is if you do it by accident, you can just make it, well, you would have to, there's other ways where you can recover it, but you shouldn't be 100% done, but like there is ways to probably recover that, but you got to be careful though. So remember, the file system is just a way to organize data, and the partition is just an empty space of storage that you're using, an empty sector, empty space of area that you want to use. So if you have a disk of 100 gigabytes, you want to partition out 20 gigs for your music. So 20 gigs will be a partition, and then you put the file system. So when you put files in there, it organizes it. You're not going to see it. Like you won't notice that. It's in the background. All that stuff is happening. And if you want to make it smaller, you have to first resize the file system. So like, let's say you want to make your partition bigger, right? In that case, you do the opposite. You make the partition, bigger, and then you resize the file system. Because you're not caving in, which is going to break the data. You're caving out. So you're not going to break any data. You're just adding more area. And then you just expand the file system so it takes all the space. Does that make sense?
Yes, it does. Yeah.
Does anybody have questions about today so far?
So I think what I'll do for us, I have some extra hard drives laying around. I will format it and attach it to the server that we use. And then maybe profile touch base with you, maybe either later on sometime this week, to see how we can format it to make it an LV drive so that they can all kind of create their own partitions and kind of practice with that.
Okay, and what I can do, I can list all the commands for you guys for the logical. Also, only command they're going to be using, we're going to set a volume group to take like 1 gig or 2 gigs. I mean, I'm sorry, maybe a couple hundred gigs of data. And then once the volume group is set up, you guys use the LV resize. You guys can do that, or you can also use the regular command like the gdisk or fdisk. But basically, like there's 2 versions. We can do the LVM way, and then we can do the regular way. But both ways, we can teach you how to increase the data, how to lower the data. I mean, like decrease the data, how to delete the partitions. So basically, all the things will be in there. So like, it's not just you're going to be doing one way, how to go back. So everything will be there. And then we can give you like a limit. Hey, you can make partitions like 10 megabytes, 20 megabytes, 100 megabytes, 500 megabytes, but don't go over a gig. So you can make like 4 gig partitions, 2 100 megabyte partitions, whatever you like, but don't go over 1 gig. That way, everyone has enough, like there's enough data on there for everyone to mess with, you know, for their profile. But you can do something like that, I think. I think that'll be a great way to do it.
Great. We will work on that.
All right, so I'm going to give some follow-up questions for, I guess, we'll go some questions the next 15 minutes, and then we should be done. But today's class is pretty much about partitioning. All the data should be on the actual notes that I made about what the differences are and things like this. So today we pretty much focus on what's partitioning, what's a file system, how to mount things and how it works, and then the file system table. So we learned about those main 3 things, which are very important to learn. So I got a couple of pop-up questions. Not sure if Nana, you want to pick people or whoever wanted to who wants to I guess whoever wants to
I
go.
think we will leave it open house. If nobody's
cool.
talking, then I'll pick someone.
Okay. Let me pull out my sheet really quick.
So while you're doing that, I just want to also kind of get a clarification. So we can also, let's say right now in our current system, right, we have the virtual drive that we utilize during our OS installation. So we did ours in VMware. So we attached a virtual or partition a virtual hard drive during the OS installation. Can we kind of modify that using the F disk to partition another additional drive from that?
It just depends how much storage you put. If you put like 100, so if I'm not sure what. So first you have to see the minimum of the system if it's 8 gigs or 16 gigs. So what you can do is put like a 50 gig drive, and then what you can do is resize it once you're in to make it smaller, like make it 40, and then that extra 10 gigs you can just use to make partitions, but use 100 megabytes, 200 megabytes, 300 megabyte partitions so you can get the practice of it.
Gotcha.
Yeah, because
I get the concept that you could modify the actual disk that's holding the OS.
Yeah, you could be able to, but it just depends because 16 gigs is not a lot. I'm not sure how much data it really takes. So you could do it, but it might affect your performance possibly, because then you're going to be like your utilization will be high.
Gotcha.
Okay. So I got the first question. What command can be used to create a new directory in Linux?
A new directory?
MKDR.
All right. Nice. All right, you got that correct. So yes, it is mkdir. Okay, so the next question I will be asking you will be what command can be used to display the contents of a file in Linux?
Cat.
Correct. You got that. Okay, so this should be an easy one. Hopefully, that's kidding. What command can be used to list the files and directories in the current directory?
LS.
Correct. ls. All right. All right.
Sound like we are only hearing from 2 people. So I would like to hear from Vanessa and Nanaya in the next question.
Okay, the next question is posted. What command can be used to change the permissions of a file or directory in Linux? To change the permissions, and for example, the read write execute bits for the owner, user, or group.
Nanaya, do you have an answer to this? And if you don't have it, it's fine. You can always, let us know at least you are in class, and then we can pick the next person so we don't waste too much time. Vanessa,
Oh yeah,
do you?
class. Well,
Take your time. So what command can be used to change the permissions of a file or directory in Linux?
is it the change mod direct what do you call it?
Smart.
The smart?
Yep.
Yeah.
Good job.
All right. We'll try another question. Okay. What command can be used to copy a file from one directory to another?
Vanessa, are you in class today? Okay. We're gonna go ahead. Whoever know the answer, you can go ahead and answer.
CP.
Yep, correct. Nice. Okay, let's see if this one will be a good one. We didn't do this one, so I'm gonna skip this one. Give me one moment. I just want to make sure that I'm getting good questions for you guys. Okay. All right.
Got you, Vanessa. Understood.
Okay. Next question is, what is sudo in Linux and what is its purpose? It's a little bit, I want to say harder, but I guess it's more of a longer answer, I guess. A little bit of a longer answer.
Anyone want to take this or should I go?
I do. Give me like 1 second.
Take your time. Take your time. What matters here is just, just trying to collect information helps it stick in your mind and your memory also. So it's good to, and even if you don't have the concept 100%, it doesn't matter because as long as you have some of the concepts, then you just attach whatever you're missing.
So I know that command is used, say that you are, you have, what do you call it, root privileges, but you're not the root user. You would input that command first and then go ahead and put in those root commands.
Yes, I think that will suffice enough. So pretty much sudo is a command line utility that allows users to execute commands as another user. Typically the root user, it is to perform tasks that require administrator privileges without logging in as a real root user. And remember, when you guys use the sudo command, you use your password.
I did not get a fraction of that.
Oh, sorry. So
no, but I know I get it. I get it. Thank you.
Yeah. So yeah, I'm buying a new mic. I'm getting I have a mic actually, but I don't like it because it's always in the way. So
no, I heard you. I was just joking. I was saying my answer was just like a quarter of what you stated.
Oh yeah, no worries. So what I was gonna say is, so like I said, just a quick recap, the sudo command, when you guys use sudo command, is you have to remember that the reason why it's used is for security reasons also, because if everyone, like, the reason why you use your own password is because you're validating yourself. You're validating that you are who you say you are. And then after that, it looks in the sudoers files to see what you're capable of. And if that command you're allowed to do, it'll run it. So most people ask, like, why don't you just run the root command then? Because if you not the root command, but why don't you run it as root, is because then you're going to have to know the root password. So in the root password, it just doesn't make sense to use a regular user. If you know the root password, what's the point of running it as sudo, right? So the reason they do that is so every account can use their own password to validate themselves. Once they're validated, if you're not in the sudoers file, it gets reported. If you are in the sudoers file, you're able to do it or you're not able to do it. So that's the point of sudo, is to give you elevated privileges if you have the privileges. All right, here's another question. How do you use sudo to execute a command as a root user?
So, so say for instance, I am a user within that machine that has the root privileges, but I am not the root user. I will input sudo. Say if I'm trying to add a user, so it'll be sudo user add, and the name of that user.
Yep.
Is that what you're looking for?
Yep, correct. That's it. All right, we got a couple more questions to go. So let's see. Trying to see a good question. Okay. What is SSH and how is it used in Linux?
I would like for Nanaya to take this.
The SSH, I don't think I was in class. Was it last week?
Yep.
Monday. Yeah, I wasn't in class with that one.
Okay. All right. No worries. Did anyone else want to take that question? There's no right or wrong answer. It's like, just see what you remember from it.
I could try.
Okay.
So I know it's a command used for security within Linux. I guess it creates some type of like tunnel, secure tunnel between the system and the server.
Mm-hmm. Yeah, I mean that should suffice. So SSH is a network protocol that allows users to securely connect to a remote system over an unsecured network. And Linux, SSH is used to remotely access and manage a system's command line interface. So pretty much, like you said, there's a tunnel that's encrypted, and you're able to connect to another system securely. But it only counts securely if there's no compromise. If your server isn't compromised, there is not compromised, or if your key is not missing, your private key is not stolen or copied or something. All right, and I guess let's see. Let me think of another question before we exit out today. Okay. So another question we can ask, because I know we went over a couple stuff. I know we had some, I think we did pretty good on the last class with the SSH and all that. Do you guys remember what command you used to generate your SSH keys for the first time?
Baf, you want to take this one? Did you do your homework?
No.
Okay. Jerry, I think you were in class.
Yeah, I did my homework. I was just looking for my notes, but I think it was SSH keygen.
Yep, that's it.
Okay.
So remember when you guys use that command, when you make a public and private key, you can actually put that public key on multiple servers. So you don't have to make a new one every time. You just make sure you keep that private key very safe. And then obviously use a password on it so only you can use it. And then you can actually put that public key on like 4, 5, 10 different servers. So that way, each time you connect, you just put the same password in and it works. You won't. So all you need to do. So in the realm of things, all the servers you're connecting to, make sure you have a user on there. So let's say you have the user Bob, and Bob, you will have to make 10 user accounts for Bob for those 10 servers. And then for those 10 servers, you can give them sudo access if you like. You don't have to if you don't want to. But if you do, you have to give Bob sudo access to all those servers. And then all you do is copy the same public key to all the servers. And then you're able to log in, but also make sure you enable actually that's only for no root login or password-based authentication. Never mind. I was thinking about something else, but with the keys are usually fine. But yeah, that's pretty much it. I don't really have any other questions. Is there any questions for me pertaining this class or any other classes? Anything that you guys still need help with? Anything that you might be confused about or anything like that? And I'm just like, this class is pretty much like, I had a couple classes before, but like after this class, like once it's done, I'm actually going to start doing like, I'm getting like all the data from you guys. So pretty much I'm writing down like a syllabus and stuff that how I'm going to do my classes next time from all the feedback you guys gave me, which is really helping me out. But your class out of all the other classes is going to be like, your class is going to like, was this class in particular, I'm basically like helping you guys out with everything. So even like after I teach you guys, I'll help you guys with the jobs and the resumes and all that, and all the connections and networking and stuff from the people that I know. The other classes are going to be totally different because it's going to be a different model. But like I said, this class, you guys are going to learn a lot, and I'm teaching a little bit extra details too, which is it's going to be good for you guys to learn. So I'd recommend you guys take advantage, ask questions, ask for resources, because this is going to help you a lot. Like I said, you might not be a Linux admin, but this is going to help you in some jobs where they require Linux. Like I just got a couple of job offers to work from home. Literally, I forgot what data center in Ashburn, but they literally said that they try to hire a couple like people from Amazon, like AWS, but they didn't hire them because they don't like, a lot of the people, like they might work with computers, but there's specific information they're looking for when it comes down to Linux, because a lot of these servers, like I said, a huge, like more than 80% are going to be using some type of Linux system. And all these switches use some type of Linux system also. So it's really good to learn. And on top of that, like I'm here to help you guys, but don't be shy to ask, because this is for your benefit, and this is for you guys to succeed, and also to find a new career, and to prosper. But like I said, all the things you guys gave me, I'm actually going to be changing out my syllabus. Probably next week I'm going to start doing like a different type of teaching, which Buffer was talking about, which we're going to be following along with the commands like we did before, but we're going to be doing the same thing, and we're going to be following along. I'm going to be asking questions in the middle of the class to keep everyone engaged. But I'm going to be doing a lot more, try to be more engaging with you guys in that sense, and also doing the pre-homework to make sure that everything should be working as expected before the classes. But if you guys have any questions, I mean, please don't hesitate to ask, because the more you know, the more it's going to benefit you.
All right, so I have a quick question. Going back to what we did today. So you saw how you noticed that you spelled like the practice partition incorrectly.
Wrong. Yeah.
So say you went ahead, you mounted it, and you noticed that there was some type of like discrepancy, whether it be spelling or whatnot. How do you unmount? Are you able to unmount?
Yeah.
And would you then like delete that file system? Or can you just quickly fix whatever that issue is?
You can be able to fix the issue if you really wanted to. So if you wanted to fix it, let me see if I can open up my terminal real quick. I'll show you guys. So remember how I named it? I use LVM. Remember, I use like logical volume or whatever.
Yeah.
So if you wanted to do that, there's a command. You use the LV change command. So you would have to, I'll show it to you really quick. So you would have to use the LV rename command, which I'll show you. It looks like this. You'll use this command, and this command will rename it for you. And if you want to do it the normal way, if you want to use the regular way, like with the F disk, you would have to do it this way. Give me 1 second. You would have to go here. You would have to replace a device name with the name that you want it to be. You press the P and then the T. These would be the steps if you want to change the name of the partition. So the first part is for the LVM, which is a lot easier. As you can see, just type in LV rename. And then the other part, you'll do it this way. But yes, you would have to unmount the file system or unmount unmount it. Yes.
Okay.
You wouldn't want to delete it, because if you delete it, you're going to delete the data there pretty much. And then it can be, technically speaking, when partitions are deleted, you can actually like get back the data. Like example, I don't know if you guys knew this, but on your cell phone, all the stuff you guys delete, and even if you trash it, it's still on your phone. All the videos and pictures. So if I had your password and you deleted everything, I can use recovery tools, because that data is just unlinked. That's it. You know, when you click on Firefox, right? It links to a program. So if that program is, if I like, let's say, let's say like the picture, it's like the link, right? So if the Firefox icon disappears, it's disappeared, but that file is still in your system. So that's the way you want to look at it. It's just pretty much a link. So even if you delete all the pictures or data, like even if you delete the partition, it should be there. You would just have to replicate what block did it start. It starts with block 200 and ends with block 10,000. As long as you can replicate that and make the partition again with the same exact numbers, you can recover it if you accidentally delete it. Yeah,
that's a little complicated. So in the event where you're saying that you can relink it, right? So how do you get back? You're not like, all right, so let's say like our file system, at times we get to it being full, right?
Yeah.
And then we delete stuff. If you are saying that it's still stored somewhere and we can link it back again, how do we get back?
Okay, I'll explain a little bit easier. So there's tools to recover. So what I mean, if I have a file system, let's say of 100 gigabytes, right? And let's say it's 800 gigabytes. No, I'm sorry. If you have a file system of 100 gigabytes, but it's 80% full, all right? And I delete like 30%. So now I have 50% available, right? Because it was 80%, I deleted 30%. So when you're deleting it, you're not really deleting it. You're just making those areas of memory available to be overwritten. So remember the file touch that we were using when we were overwriting files? So think about those files now, instead of being protected, now they're unprotected. So so basically when you save stuff on your computer, it can overwrite those areas that are put for deletion. The data is still there. It's just going to be overwritten. That's it. And if it gets overwritten, you might be able to find parts of the code that you might see like half of the picture or parts of the picture or part of the song. Like it'll be like pieces of data. But if your file system, if your computer never decides to overwrite it and it overwrites it, and if it's like writing data somewhere else, it'll still be there. So like I said, even on your phone, there's apps where you can actually like see what people are deleting on your phone. So I mean, I don't want the cybersecurity stuff, and that's some other stuff we're talking about. But I thought it was an interesting thing to talk about, because when you delete stuff, it's not really deleting. You're just telling the files. You're just telling the operating system, hey, if you have any new data and you need space, you can overwrite it here. That's all it's doing. It's not protecting those areas of data, like those those blocks. Like it's like a storage bin. Think about your storage bin, right? You have a storage bin and you put toys in there. So usually it's protected. Like, hey, no one can save it. This is David's storage. No one can put it unless David does it or David does what he wants. But when you unlink it, right, the data is still there. So somebody else can come and take stuff out and put stuff with, or like do whatever they want with it. So think about it like that. When you guys are deleting files and stuff, you're just freeing those areas of memory for the OS to save stuff on top of it. So you're pretty much just overwriting the data, but it's not 100% deleted. You can still recover it, but there's ways to do it. Unless like your computer overwritten it or did something with it, but yeah.
Gotcha. Understood. Thanks.
Yep, no problem. Any questions for everybody?
I think I'm just going to ask one more question to anybody in the class, and then we can end there. So if you want to mount a drive or device, what command do you use in Linux? And then we can close for the day. This is from today's class. So anybody in the class, if you want to mount a device, what command do you use in Linux?
The mount.
You use mount.
The mount command with the key above
the pipe.
Yeah, above that. Was it shift?
Grep.
So
mount pipe. Grep.
Can you repeat the question again? Whoever repeated that question. You said
if you want to
mount
something.
Okay, so yeah, so if you want to mount something, remember the grep command. It's just the mount command. If you use it by itself, it tells you everything that's mounted. But if you want to mount something, you have to type in mount and then the partition that you want to mount and then the location on the directory. So the mount command, when I did the grep, all I was doing is using the mount command by itself. And when you use it by yourself, it just gives you the list of all the things that are mounted. So I use the pipe command or the pipe operator thing to grab the data, to put it into grep, to look for something called music. But the mount command by itself just gives you all the things that are mounted. But if you want to mount something, you have to use the mount command, the device or the partition, and then the location where you want to save it or store it, pretty much. But that was really close.
All right, that's it. I think today's class was very interactive, and I would like for all our classes going forward to be like this, guys. Good job in answering some of the basic questions today. I'm really happy.
Yeah, I mean,
that you guys are picking up the information.
Yeah, that's all that matters. I mean, honestly, like you don't even have to be right. Like I'm wrong sometimes too, but I mean, it's like it's good because at least you're trying, you're making an effort, and it's slowly gonna help you. But let me show you guys something real quick. This will just take like less than a minute of time for everyone else about the mount command. So remember when we do the mount command by itself, everyone can see my screen, right? Cool. All right.
Yeah.
So when you type in the mount command, you see it just tells you everything is mounted. There's too much extra stuff. Who cares about this stuff? We don't even need to know what it's about. But if you see on the bottom, you see I have my RAID. It's like a RAID partition or whatever mounted. But all you have to know is that when I did the mount command, I did it off of LS block. And LS block, I have this partition here. Now it's 500 megs, so you guys can see. So now I'm going to copy this, and I am going to do mount. So you can also do type, and I can do ext ext2 if I really want to, because I know it's ext2. But the mount command is smart enough to know what file system you're using. But I can do type ext2 if you like. You don't have to, but you can. And then you have to give it the location. So it's under dev mapper. And then remember it's under VG practice 1. And then I want to mount it under music. And then I have to use sudo to super user to do it. And as you see, now that I did that, I didn't have to do ext2, but I know it's ext2. That's why I did that. But if you take this out, it will do it on its own because it reads like the blocks. Oh, it says it's ext2, so we're good. So once you mount it, right? Now you can see if I do ls block, you should see music here. You see music? Music is mounted now on this partition. And it should say, and then if I do this command, it's called the dump e2fs, and I can do this on the dev mapper and on this partition. Sorry, wrong partition. So we do it on VG0 and then practice. I forgot what it was called. Let's try this. And then we're going to delete this so I can show you guys how it looks like, which will be cool. So the reason you might want to ask, like, how does it know what kind of file system it is without putting that flag? Because I remember I put ext2, but this is how the computer knows what it is. So if I use this command, you see it tells you here. I should tell you ext2. Let's see, it tells you the volume system. It might not be this command, but usually it's one of these commands that will tell you the exact file system, but whatever. I was just trying to show you that the system knows by the headers or whatever that's in the actual system. But all you have to know is that when you mount it, just use the mount command, where the partition is, and then you can actually put what directory you want to mount it to. And that's pretty much it. All right. If there's any questions, I can answer. If not, we can conclude for the class for today.
Okay, thank you so much.
All right, thank you, Prof.
Yep, no problem.
All right, guys. See you next week, and please be on time. See ya, and enjoy your weekend or the rest of the hour.
Yes. All right.
All right.
Bye. Take care. Bye.
Bye.